Hello everyone, let's wait for 2 minutes until everyone joins. Okay, I think we can start. Welcome everyone, and today we're going to finish talking about the exceptions. Then we'll start the discussion about the collections after that. But yeah, at first let's start with custom exceptions. Yesterday we already defined some custom exceptions which can be used in the way that you provide some information to the exception, and also they can be used as the markers, like just to distinguish that this exception is thrown, yeah. But yeah, as a developer, yeah, as a test developer can define custom exceptions, and yeah, to write the exception, to create the exception class, you need to extend the class which is also the exception. So uh, if you yeah, that's and also you need to have superclass, which is a subclass or the class of exception class drawable. And yeah, usually it contains two constructors. Yeah, as for all the classes, so just please note that, as I said yesterday, all the exception classes are also like kind of same way. The classes defined kind of same way as all the classes in Java do, but with some specific methods and specific arguments. That's why again all the things about the encapsulation, inheritance can be applied to exception classes. And yeah, as it stands here, there are constructors as well, yeah, as in usual classes. And usually, if you define custom exception, there is a default constructor, a simple constructor without any arguments. And yeah, we choose constructor or superclass, and another one with, for example, with string argument, which uses similar constructor from superclass and adds custom message properly to customize exception object. You can also as I shown to you yesterday, we can also provide some parameters, specific parameters. Like yeah, maybe let's have the example now, so we can easily just imagine we have the voting, yeah. Just voting. Let's have voting class. And imagine you have the list of. Imagine you have just a simple voting. Here we define a new array. List for votes. Yeah, let's mention that each vote is the vote for the corresponding candidate. Yeah, and here we want to do the voting. Yeah, just for example, have the void apply to vote. Just maybe that's just a vote. Then we also can have, let's call it public. Here let's mention we have the candidate name. And here we must check if so if the person is allowed to vote or not. Yeah. Hmm. Maybe let's not be the vote. So, public string. We'll need to return the string at the end. Maybe let's do it even more better. Let's just create the static list. So basically, it's also the just small reminder. What's the difference between static and non-static variables? This is kind of the way how you can visualize and imagine the static. How to use the static variables. Like imagine we have the voting, yeah, and for every person, the voting is a different process. So everyone goes and votes, yeah. But there's also the lists, the box of votes, and which is the same for all the voters, yeah, all the participants. And in this case, we can just imagine that we have a static box with all the votes for all the voters, yeah. So what we can do here, we actually just put, maybe for this case let's not use the string, but so, and for voting we can have some restrictions, like for example age, yeah, there's an age check that the person must be at least 18 years old. So here we can define the exception. We're going to invalid age. That's also an exception. Then we want to extend the exception class. And for here, we can again have the constructor. So usually, and for example, here we can have the initial constructor as it standard there. So we can have this kind of text which we want to provide. So as you can see, superclass also has at least two types of the constructors. Someone wants to join us. Yeah, the superclass also has the constructor with no parameters and with string as the parameter. But we can also define our own constructor. And we can also set it up in this class as the global variable and set it up in the constructor. Right, and we can also print it out. We can use the method from from the superclass. Can also do the superclass as well, and H is not valid for vaulting, okay? For example. Check out, then if and let's have the class person. Have the age. Okay. Private integer. Constructor which defines the age of the person. Let's just define the getter method, which returns the age. And again, can provide the water, yeah. And firstly, let's also we do it this way. Let's not define it this way. Just let's have as the object, and in the constructor let's pass the water, yeah. Then we have the candidate, and we can first we can check if it is allowed to vault. Then if it is allowed, then we can pass we can add the candidate to the box, to the list of votes, yeah. And here we can check the age. If not, yeah, okay, maybe let's do it that way. If this, oh, sorry, water again. Get age is less than 18. Then we want to throw the exception that, okay, maybe let's do it this way. So, because I don't want to call the method twice. Yeah, put it this way. And as usually, if we throw the exception in the method, we need to provide this information on the definition of the methods, yeah. Same as here. Just go up to the hierarchy, and so now we have the voting system defined, and we can and we can we can do the voting here. Sorry, main, and for example here we can create the person. For example me. Yeah. Just an example. Define a new person, and let's imagine that I'm just only 14 years old. And after that, I imagine that, so I assume that I can go voting, for example, and vote for someone, yeah. Yeah. And here I want to go vote. Let's imagine I want to vote for no for any candidate, yeah. It had to be any candidate, for example. No matter, but yeah, as usually, so that's also if you compare it to the actual system where you go voting. You cannot vote without without providing the documents to these commissions, yeah. So to the place where you vote, you must provide the document. You must be at least 18 years old. Like, yeah, in Latvia, in some countries it can be different. But yeah, you assume that you are not allowed to just vote without any validation. The same is here. It shows that you cannot vote without the checking, and it's possible that you will not be allowed to vote if you don't pass the all the necessary requirements to vote. And yeah, as it shows in this case, you need to assume that some exceptions may be called. Yeah, just one moment. Let me yeah, as Wayne is asking, voting class. So in voting class we have the person, which is actually the voter who will vote. Then we have, yeah, maybe let's just move it on the top so we can have. So yeah, maybe start with the top. So now we have the list of votes, like all the votes for in the voting system. Just a list of votes. So where there are all the votes, yeah. Then there's the person who is the voter. Because yeah, that's the class, that's the object for, yeah, that will be the instance of the object for voting. Then then in the constructor we just pass to put to the subject who is the voter, yeah. Then we just want to vote for the candidate, yeah. And first we will check if this person, I mean, if in this voting instance we can pass the vote for the candidate into the box of all the votes. And yeah, here we get the age, and we check if the age is correct or not. And in the exception class so in the age exception class we define the age, which is the age for the candidate. Then we just do some simple stuff. We call it super constructor. So in theory we can skip this, but yeah, that's just to show that can be done this way. Then we have the constructor with the age, so we just pass the age to this exception, and after that we just print that we have this error here, and here we can print this error, for example. So what more do we can we have here? Like so imagine that in the voting system we have such problem, not problem, but requirement that the voter must pay all the fines he she has, yeah. So then fines not paid, for example, yeah. Again, that extends the exception. So, for example, we can have the and just the amount to pay. Okay, there's a question from Svetlana. Could you explain the way for invalid age? How does it go through a pro? So yeah, here we just have imagine that there's just a simple voting. So there's a person who come to vote, yeah. Then so imagine that's me. I want to vote. So I'm the person, and I'm just 14 years old. Then I just I create the instance for voting. So I go inside the voting place. Yeah, yeah, yeah. Here you can easily see that I go inside the voting place, and I want to vote for any candidate. Yeah, just imagine there's an option to vote for everyone. Yeah, for example. Then yeah, I'm the person. Yeah, the person has the age. Then I want to vote. So I go to this method and I just want to pass my vote for the candidate. But firstly, before I'm allowed to vote, I need to check if I'm allowed to vote. Then then the check happens. So I get the check checks my age. Then it checks if I'm younger than 18 years old. It throws the exception that my age is not valid for the voting. Yeah, and let's imagine that we also can have the exception for like if you have any fines, any bills which you have not paid before, you are not allowed to vote, for example. And then for this one, you can also have the constructor to pay. Constructor to pay, and here just can set up how much should we pay to be allowed to vote, for example. Yeah. Yeah, like any debt we have. Yeah. So imagine the person has the debt. Like imagine that every person can have debt. So we check if maybe debt paid would be. I think that would be better if it's undefined, but just debt. Yeah. And yeah, let's imagine that. So that's the person. Okay. So why it shows that it's not used? Okay, we need to get depth as well. And yeah, by default, maybe let's set it up as 0. So let's imagine that the person does not have any debts by default. No. Yeah, so okay, that's pretty it for the person. And yeah, you need to pay maybe. Yes, maybe it's not. Yeah, and in the and if you want to print it out, don't really want to something from the superclass. I just want to print it from here. Okay, for example, you need to pay. Let's imagine that the person actually don't need to pay the full debt. Just okay, maybe let's maybe do it this way. Like we have the debt, then you, for example, needs to pay kind of. Yeah, let's have the static variable percent to pay. Yeah, like imagine you. So just to be allowed to vote, you need to pay at least like 20% of your debt, for example. Private static final string, not string but integer percent, and like imagine you need to pay 20% of the debt, and you have the string gets to pay. Let's have the debt here. So here return percent. As you remember, you should use the uppercase for. Sorry. Uppercase for the constants. Yeah. Since this is the percentage, you need to do it by 100 and pay that, for example. Yeah. And here you can. How much do you need to pay? And okay, maybe let's not do it this way, let's do it. You need to pay the debt, and let's have it public one. So yeah, and in the exception, so we are in exception clause. Yeah, don't forget. Here we can get the how much do we need to pay to be allowed to vote. And in the same way, so in this case, throw will work as a return statement. Yeah, because if we catch the exception and it's not caught inside the method, it will return, I mean, it will go out of this method. So for here, again, we also can check if this order get depth is greater than 0, for example, we can throw new depth not paid. Here we can, okay, maybe let's do it the same way as here. So, because for some cases, the logic for getters can be a bit complicated, so it's better to, so if you use them more than once, then for the first time just read them and store them inside the local memory, inside the local variables. So for here yeah. And as well, you need to provide which exception to be called from, to be thrown from here, and same is about same as here, and obviously the same as here, yeah. So you need to catch another exception, debt not paid, and like at the same day you can pay the debt. Yeah, first of all, maybe let's print something is wrong, and then you, for example, you can pay what you need to pay to be allowed to vote. Yeah, and so here and here you need to, here you can have the method, not integer but just void pay debt. So here you have the amount you can pay, and you can subtract the amount to be can decrease your debt this way, yeah. And for here you can get the how much do you need to pay to be allowed to vote, for example. Get to pay. So now you so now you can try again to vote. Yeah, no, so first of all you need to pay for the debt. Pay debt, and here you can pay as much to so you are allowed to vote, and after that you can try to vote again. For the same candidate, yeah. And in this case you also need to do try catch, and for this case yeah, it's not really the best way to do, so maybe let's just okay, maybe okay, we can also do try catch inside the catch, but I think in this case that would be okay. In theory what we can do, yeah, like in this case too, try to vote, and for example boolean, like if we point if I voted or not, so by default I do it with false. Voted equals false. Yeah, and in this case I just want to retry to vote. So otherwise I just return that I have not voted here. Yeah, or and here at the end I can. So if everything is correct, the exception is not caught, I can point that I have voted. False true. Sorry. So here was what I mean. No, yeah, Svetlana, I'm not telling that the Boolean is something bad or good. Basically, the idea of using Boolean for validation is not good. Like if you go to the program and you need to validate something, then you for validation you use Boolean. So again, I'm not saying that Boolean is something bad. I mean, what I was saying yesterday, that to use Boolean approach, like if you just yeah, if you do some stuff, then inside the stuff you can have some errors. Then you check if it's completed or not. You use Boolean. In some it's very good in some cases, and it's fine in some cases, and in most cases it's fine. But in case you just want to finish the program execution after the not execution of all the program, but for some statements and some blocks, you it's much better to use to control the flow of the program. It's much better to use try catch. But in this case, so basically what I do, I try to vote. So that's why I just do while I have not voted. So that's just a pointer to point that I voted or not. Yeah. So I just like imagine standard process. I go to vote, and so until I have not voted. So I have not voted. That's uh, that's what is mentioned here. So by default I have not voted before I put my vote into the box, yeah. So that's what I try to vote, and until I have not voted I cannot, so I don't go out, yeah. So what happens here? Maybe let's just yeah, for a person, maybe first of all, okay, let's imagine that, let's start with this case, and maybe I would like to debug, because that would be easier to control the flow. So we are inside the voting and we want to try to vote. We go inside, then we check if the vote is a vote. So we have the age, and we also check the depth. If the age is not valid, then it throws the exception, it constructs the exception, and it prints that the age is not allowed, and we just go out of this program, yeah. So nothing more happens. In case we have something to pay, which is not paid, and because yeah, in this case you can see that we cannot do anything. If you are not 18 years old, you actually cannot fix this problem immediately. But in case you need to pay kind of debt, you can do it in the same, like in the same day, maybe in the same moment. Like imagine that you are kind of 24 years old. Just a simple example. And here we want to vote. And sorry. Yeah. This. So yeah, maybe let's do it this way. Just run. In this case, we can let's see even more. Let's print. Thanks for the vote. Yeah, for example. Yeah, so I voted and everything's fine. But let's imagine that I'm not saying not this, but me. So imagine I have some debt, yeah. And for example, by the law, I'm not allowed to vote, yeah. So like it's not in the rule. Maybe it's not the real example. It's just sorry. Oopsie. Content. Okay, I think we have some errors. Let's see. What's the problem here? Okay. So let's debug. Let's see. So we try to vote here. We check if it is allowed to pay, and it says no, we are not allowed to pay because we have the debt. And here I have, oh yeah, that's, maybe let's skip this one, because just imagine that you need to pay everything, yeah, because that would be a bit complicated, yeah, if we just, so again we we try to vote, we go to catch, it shows that I need to pay the debt, so I get the amount of how much should I pay. Then I paid this debt, and so for now I don't have any debts and I can vote, and everything is fine here. Yeah. So that's the simple idea how we can use our custom exceptions to explain the way how the voting happens. Yeah. Yeah, just please note that exceptions are are just the same class as all the classes, and when the exception is thrown, we can see that it also has the parameter. We cannot catch without the parameters because it doesn't make sense, because in catch you need to provide which exception can be thrown. Yeah. And in this case the exceptions are the objects with refer to the exception classes, and so the objects is provided as the variable. Yeah, in most cases we use e. Here you can use whatever you want, so this is just importing variable here, which can be used as the simple object after that. Yeah. Yeah, certainly we do need to final variable because I just to not overcomplicate this example, because otherwise that would be a bit more complicated, and I don't really want to go as deep at the moment. Yeah. Okay. Yeah. Thanks, Marita. So that's basically the idea, and of course you can again in this case we just try it twice. Yeah. Like we vote. It's so yeah, basically what was before was the problem that so yeah, by the concept of this program we are not allowed to vote before the debt is paid. Yeah, before the full debt is paid. And what I wanted to implement, I just wanted to like not pay everything but kind of 20%. But again, by the definition of this program, we need to we are not allowed to have the debt at all, so we need to pay everything. Yeah, in theory we can make it a bit more complicated, like to pay to have the exact amount to pay, to have the exact percent to pay, but I don't think that we need really to go so much deeper in this example, because here I just want to show that we can have some invalid some exceptions on some checks on the voting, so yeah, we can use exceptions this way. Okay. Yeah, okay, I hope that explains you a bit more about the exceptions and the way how we can use them. Okay, see, that's what one and okay, yeah, it's good. Sweatone is typing something. Okay, let's wait a bit. Yeah, no, try can't have the arguments because that's just simple block that we try something. Yeah, maybe if you can imagine why can we have and what can we do with the arguments and try. maybe you can, so in theory they can be passed to the exception class in some way, but that could be a bit problematic because basically what happens if again, let's go back to our stack painting. So we have the stack, we have the try somewhere here, then we have the throw somewhere here, and as you know that the that so from the start when we were talking about the stack memory, so everything what's located here is yeah, not located but defined here in this place. So that's its place in stack memory, and in fact it is not available from other stacks. Yeah, so if you have something defined in this stack, you can pass something to the stack above, but not everything. And in theory, so we have try statement here. Yeah, so I have try statement here, and in theory there can be some variables, but in fact these variables are not available here. In this case, the exception is built only based. Yeah, imagine that here we throw the exception, and the exception is based on the stuff located here. So that's why it passes the information to here. And in theory, if we go to catch here, if we go to catch here, in fact you'll see the variables from which are defined before try. So in this case you'll have all the information in catch block. Yeah, so you have try, you have walk, you try to do something, then you have catch, you also do something, but in fact so when you are in catch, you actually have all the information provided before try. Yeah, that's why there is no need to pass something to try. Yeah, because basically in catch you have everything available what was defined before try, and that's why you don't really need to have any parameters inside try to be passed to try. Yeah, and you are not allowed to, because by the construction of try catch as well. Yeah. Okay, let's have 15 minutes break, because that's Saturday, and I think we all need, and we have a long session today, so I think we need to have more rest during the breaks than usually. Okay. Okay, let's make it 10. Okay, we can move on. Hope you can hear me. Yeah. Okay. So yeah, there's some some questions came to me in Discord. I will, as usual, answer them at the final part of the session. So let's move on with the presentation. So from here you can see some one custom example from the from the from the exception from the custom exception class. Um, it's also an option like example if yeah, just maybe let's create one more parameter like example static private string voting place. Yeah, like imagine there's a special place where the corresponding person can uh, can vote. Imagine um, that's the first grammar school, for example. So yeah, let's write it in uppercase. So and also we can validate uh, the person's voting place. This question from certain. Yeah. Okay. So yeah, I mentioned the person can have the voting place. So basically, the place where the person can vote. Yeah. Private string and voting place. Here we can, for example, set up, or maybe let's just set it up using set voting place. Don't forget. And first, yeah, let's set up. Place, let's mention it's other place like the second grammar school, for example. So and here we can define again a new custom exception. And yeah, in theory we can have such construction as stands in presentation that we just we just pass the string as the message here. Okay, maybe let's in a constructor. So here we can maybe let's just we can pass the string. And call again the superclass. As an option, you can do it this way. What else? And also you can have the parameters inside the exception attributes. That's what I called. Yeah, in this case, we'll just use the construction where we don't pass any parameters. So maybe from here, if this voter yeah, get voting place not equals voting place, then to draw exception. Place exception, then you can pass some kind of text. Voting place. It's not like that's right and not correct for you. And yeah, of course, here we also need to throw these exceptions. Can print struct trace, for example. Then let's see what do we have. Sorry again. Yeah, my fault. I just forgot to return. Yeah. So now we go to the endless loop. Now we go to the endless loop. Yeah, because here if we don't return here, we just go to here, and that is called endless loop. So in case I don't have another try, I just go out of the method. If I want to have another try, then I don't return anything. And yeah, for now so now we can see that this exception is triggered, and here we see the string message we just provided. Yeah. And yeah, so that was so what we can see here, we extend the class exception, then we call the constructor of the exception class, and we pass the text, the string, to this constructor, and we can see that the text will, if we print the stack trace, using this method, print default stack trace method, not default, but yeah, that's default one, because we do not override it here. That will provide the name of the exception. Yeah, wrong place exception. Then you have the text, which is provided here, and here you get the actual place where where the issue occurred. So we have voting method on line 96. So yeah, that's the place where the exception is thrown from checkout class, from checkout method, sorry. Then so yeah, basically yeah, Sweatone asked for constructor, but yeah, that's the constructor for exceptions. So in theory, so exceptions may have two, like it has the simple constructor. I mean, okay, maybe we can even go deeper here. So we have the, okay, we have the constructor. Again, we have two constructors here, exception and exception with the string. So if we go to the constructor with, sorry, no, go to constructor from Strobo, then it fills the stack. Yeah, first of all it fills the stack, then it passes the detailed message, but yeah, I think that's a bit deeper. If we go a bit deeper, basically, yeah, you can check it yourself if you want, but that's not really important about the construction of the exception class. It's just about how we use it. Yeah. Yeah, but it's very good if you ask it, if you're interested. But yeah, just simple idea is that there is a framework of exceptions which can be used this way. Yeah. So again, we have the exception, then we have the text provided, and it basically shows where is the place the exception comes from. So we have the line of code, line 96. This one, it shows that it comes from checkvote method, from the voting class here. Yeah, and this comes from test voting. Yeah, again from voting. It comes from voting, then from vote method on line 86. That's what's written here. From here we call checkout, and checkout throws the exception on line 96. And actually this this one is called, so this is method vote, which is called from main method line 20, yeah, from here. So by following this stack we can actually find the place where this exception comes from. If you don't have the text here, yeah, like imagine we don't have the text, just a simple constructor, then it's actually the same, but it does not show the text message. So in this case, if we want to provide some information, we can use the string. Also, we can really redefine almost everything here and just create it by ourselves. Yeah. Okay, and then a little bit about throw statement. Yeah, you can throw the exception to inform that there's some exceptional event happened. You can use it in your program flow. Then you use throw statement. You create so basically in throw you just again after the statement throw you just create a new object. Yeah, new object. You pass the class of this object, which is basically exception at the moment. and you throw this object and you pass it to catch block. So again, just small reminder here, like in this case it goes from here, so you construct new object in this, so here you construct new object, then the method throw passes it to here. Yeah, you have the catch, you have the class for the catch, and here you have the variable to which this object is passed. Yeah, this object. And if you have the message, you can again use the string to pass the message as I showed you there. And this is also kind of this is the example. You can have the method which throws something like server timeout exception. Then you have the parameters in this method. You try to open the server, try to connect it to the port. And then if it's unsuccessful, you can throw server timeout exception, timed out exception. Yeah. And pass the message that you cannot connect to the port with the port number 80. Yeah, and here there are some exception handling methods. Okay, maybe let's just go directly here. Yeah, again, in custom exception classes, you can define your own from here you can define your own methods. That's also fine, as in all classes. And yeah, once you have the object of the exception return, you can have some methods here. Like here we already use string stack trace, which prints the stack. You can also use method get stack trace, which will return you stack trace element, which is also the class here. It's the array, which is the array. Maybe let's use debugger to check what does it actually mean. So that's the array. So that's the array with some stack values. In this case, this the classes. Yeah, if you can basically put everything in your stack, so everything will be stored as the array. Not everything, but I mean every this entry will be stored as the element of the struct trace element array. Yeah. What else? And yeah, the element itself can store, like in this case, it can store class name. This one, yeah. class name, then file name. It's the file name. Let's maybe just yeah, just check the first element as the example. So yeah, you have the file name. So that's test voting Java. Let's go maybe to class name. Class name exceptions voting. This one. You can get it from the stack. Then the line number. I think that's obviously this one. Oh, sorry. The exception I expected. And the line number. Then so yeah, that's the second element. I mean, let's go for the first element. I just so yeah, number 898 should be here, yeah. And number and yeah, the method name as well. So you can have the method name from which this exception comes. Yeah, just as a simple example. Or we can use the stack trace element. Yeah, in theory, as yeah, also what you in your X206 activity, there's such thing like log, and yeah, as I mentioned, if you logs are needed to actually place the information about some actions happened during the execution of the program, and if you have the exceptions which are raised inside inside the program, so they can also be the information about these exceptions can be shown in the logs, yeah. And yeah, to get to actually to process this information, to create these logs based on the exceptions, you can use these methods, yeah, like the class from which exception comes, and the file name, the line number, and the method, yeah, just in case you need to provide the information about the exceptions raised during the execution of the program. Yeah, in throwable object, there's an implicit method to string. Yeah, the easy option to get is class get message and get cause of throwable null if unknown, and get message. Maybe let's just have some. Sorry, I just accidentally closed the presentation. Let me open it again. A moment. Have get message. So again, remember that exception class is the subclass of class throwable. So that's why it also inherits the methods from the throwable method. Yeah, just maybe let's don't print everything from here because I don't really need it. So if you want to get message from exception, you just get the string which is passed to the constructor of this particular exception. Yeah, so that's basically, if you use get message text, that's this text, yeah. So excuse me. Get message. Then what else you can have? Get calls. Yeah, in this case that's Lucas. One moment, let's so check what's. Yeah, you can see there are lots of constructors here, and for one constructor you can also have the calls, which is also exception. So you pass the exception, not exception, to throwable thing, which can also be the exception. So you can pass the exception to the constructor of exception. Yeah, that's I think that's quite similar to the Martian, which can eat another Martian, which can eat another Martian. So that's the recursion, same as for the Martians. You can have one Martian stomach of another Martian. That's quite similar to exception, which can store another exception inside. Yeah. That's about costs. For the localized message. Okay, I think that's the same for us as our simple message in our case. So yeah, basically what you can see in the constructors, again you can have multiple parameters to message, then exception, just exception to the exception, and yeah, some other parameters as well. But yeah, that's what about the methods. Here's also one code example. Here you can print the message, then you can print the cause of the exception. The assertions, yeah, I already mentioned about them this week. So these are the statements which should be true in the code execution path. Yeah, so if they're false, then you have a serious error. And again, assertions are not usually used. Yeah, they're not basically they're not used in the programs which are used in production systems. So if the program is used by the users in real life, it's most likely that assertions are turned off. But in most cases, assertions are used during the development mostly. So if there's development, you just need to check if there are no serious problems there. You use the assertions and check if there is a problem or not. So the general syntax is that you have an expression 1, you can have multiple expressions, expression 1, expression 2, for example, and yeah, one linear statement. And yeah, it throws assertion error without any message properly set. So, and so I think that was mistype. So yeah, it's not true. for second syntax, expression 2 is used as message property for assertion object. Yeah, and by default they are not checked. And to I think I have. Let's just use simple or something like that. No, maybe let's just create a new new class. So here imagine you have something. So just static, public static void. And yeah, just let's have some basic statement. Sorry. Sort a equals 3, for example, and here we call this method, and by default I think there should be no problems because we turned off the uh, turn off the assertion handling. So if we write EA to VM arguments and we run, we can see that, oh, sorry, not this one. I think that should. Okay, let's strange. I think that worked on Monday at least. Yeah, so okay, maybe we need to apply. Yeah, we had to apply here, and what we can see that now the assertion is occurred. Yeah. Okay, in theory, we can also have a different another method. And just yeah, maybe let's this way, just in case we want to throw this exception. Always we can just use assert true, and that will not in this case because it's turned off, but if we use it with EA argument, okay, and in this case that would be fine every time, but if we assert it as false, that will trigger the assertion error all the time. What happened when I run the program? When I just run the program, it called this method, and the assertion statement was executed. So basically, if we write assert, then we write the condition. If it's false, then we got the assertion error. So basically, when I run the program, just use run configurations. Then I pass the argument to VM, to virtual machine. And here I just point that I want to enable assertions, yeah. And again, where it's used, if you have the program and you want to use it for the testing, like you have two ways of program usage. Like if you have the way to demonstrate something or to use your program, you do not turn on the assertions. If you want to use the program for the development, you want to check if there are any maybe non-serious or non-crucial errors in the program, but you actually can fix them. You can use assertion, which will add kind of allow you to do the additional checks on the program, and in case you have any problems, that will trigger the assertion error. Yeah. So that is used just to simply enable or disable the assertion throwing. If you just want, again, if you want to use your program, you don't enable the assertions. If you want to improve your program, if you want to kind of fix any issues there, you can enable assertions, and just based on the assertion exception, you can fix your program. Yeah, okay. Let's move on. There are a few slides here. And there can be complicated assertions. Yeah, one assertion. Remember that assertion errors throw when assertion is false, yeah? Yeah, so we have the statement which returns true or false. And if it's true, then assertion is not occurred. If it's false, then assertion is occurred, and it will throw this assertion exception after that. Yeah. But it could be tricky to sort for a combination of some negative scenarios. Like if you have some statements, some statements which need to be checked, you can use again the brackets. Then you can have the message, like in this case. Okay. And if you run it using the parameter for the virtual machine, you again, as for all the exceptions, you can have the message that assertion is not true. So basically that's maybe the equivalent way for this one. Like if you throw So yeah, in this case, what's the difference between yeah, maybe let's just have some. Yeah, that's not the correct example. It's just explanation. Yeah, imagine if you. So again, assertions are kind of the same as all other exceptions. So you have. So in this case, that's the stack. You have some information in the stack, like the place from which this exception comes, and the string message. So that's quite simple. That's quite similar as if you just simply throw the exception from some class. Yeah, that's okay. That's not correct because you cannot throw the exception from this class using this thing. But that's just explanation to which what are the similarities between them. What else? You can see that there is no. We don't point that this method can throw the exception. Yeah, you can see it here. We just use assert statement without any pointing that in this particular method we can have this error, which is also the maybe tricky point here. So, and yeah, basically again it shows that assertion is mostly used for the testing purpose, not for the actual production programs. Yeah, in this case we don't even pass that we throw something. And in case again why it is needed, if you just simply write the program, you don't need to build even such, yeah, from my point of view, simple construction, like not simple but not really complicated construction of try-catch statements. In this case, and yeah, imagine you have the program, you need to build the program, then you have the flow of the program when something wrong can happen, and that's fine from the program point of view. So it's not something that is really unexpected or something which is absolutely not correct. Like in this case, what we had voting. So in theory, that can be in real life that someone who is not 18 years old goes to vote, and then the voting commission do not allow this person to vote. Yeah, in theory that's quite simple case. It can happen. That's fine, and there's nothing that we nothing 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 wrong, and nothing you can't really imagine that this can happen. Yeah. So in this case you use try catch, and that's the simple program flow which can be controlled using the exceptions. But then what you have, like I'm not sure if in this case you can imagine something like this, but imagine that something unreal your program does something unreal, which is not what you actually expect to have. I cannot really imagine it at this particular point, but I think, yeah, for you, please imagine that this can happen. Like you want to load some material from somewhere. This material does not exist, or you provided something incorrect. So basically, if you if you consider that you have something incorrectly implemented in your logic, yeah, that's also the point. So yeah, that's everything is fine with voting, but you have some missings inside your implementation. Yeah, so you have something wrong in your code. You don't have something wrong with the input, when user input, but you have something wrong with your code. Yeah, and for this point, you don't need to control it by try catch, because that's not the thing which can happen in real life and which should not happen in real life. I mean, in real life you should not have any errors in the program normally. Yeah, I mean the errors which are not expected and don't need to be there. And in this case, you can use assertion to check if you don't have such errors inside your program. Yeah. I hope that's pretty understandable why the assertions are used. Just for the testing purpose, yeah. Just to clarify if you don't have the issues which are not expected, yeah, are not expected in real life. And yeah, also what you can do, yeah, in this case it's yeah, just simple logical expression. um, so there are so-called De Morgan. Well, let me show you. That's from. So if you, that's something from mathematics. Yeah, you just you can use it in the programming. So if you have the statement um, 1 and statement 2, and you just use okay, maybe let's use not, but it's also not the trick, but okay, I mean, you can consider this as a trick. So you have statement A or statement like in Java or statement B, and you want to press it not, yeah, not statement A or statement B, and this is equivalent to not A and um, not B. So you change the sequence. Yeah, you change the sequence of the not the sequence, but you just apply the operations this way. Yeah, not operations this way. Yeah. So you have again something which returns true or false. Yeah. Again, if it's not true, then it's false. If it's not false, then it's true. I hope that this is pretty clear from the logic points of view. And if you type not expression A which returns true or false and expression B which returns true or false, then that's the opposite one which is returned from this expression. So you have true or true, you have true. If you have true or false, you have true. If you have false or true, you have true. If you have false or false, you have false. So at least to make this one to be true, you need to have one of these to be true. And yeah, the opposite way with the false. And yeah, this goes to the opposite one. So, and this is the same. You can write the statement the same way, that you take the opposite from statement A, and you add true operator, and you not true but the and operator conjunction, and you check it with not B. Right, so that's basically the way how you can use it. And yeah, for AND operator it works that, as you remember, maybe you remember, true and true, that's true, true or false returns false, then false, true returns false, and then false and false returns true as well, or returns false as well. So the only way you can get true using operator AND is you need to have both statements true, and so these are the so-called De Morgan's false. The same way for AND operator, you have not A and B, which is the same as not A or not B. Yeah, that's, and yeah, for in set theory, that's quite interesting that you can use this logic using the set theory. Like here you can easily see the De Morgan's law using the set theory. Like we have two expressions in our case, yeah. In this case, these are true two sets, set A and set B, and you have the intersection of these sets. So you need to have something which is something outside the concatenation of these two sets. And in theory, you can also see it as the intersection between the sets which are outside B. So you can see that outside B you have basically everything here, and outside A you have everything here. Yeah, so from here. And basically what it is outside A and B, like in this case it means that you need to concatenate A and B and take everything what's outside A and B. So that's this blue area. And again, that's the same if you have the intersection what is outside A and outside B. And as you can see, this is the intersection. So basically we take everything what is outside A and B, and also we don't consider this one because that's the intersection of A and B themselves, yeah. So that's for if you want to take the opposite from A concatenation with B, and if you have the intersection, so the opposite of intersection of A and B, like in this case you take the intersection A and B, this one, and you want to take opposite from this intersection. That's the same if you take the opposite of A. So the opposite of A is everything what's outside A. Yeah. So from here to all these blue area. Same for B. Opposite is here, and we just want to include and the unification, yeah, the concatenation from something which is outside not A, which is this one, something which is outside not B, outside not B, this is this one. So at the result we have everything, every bool, all the bool area here. So that's, and we exclude what's inside this yellow area. Basically, this is the explanation of De Morgan's law you can use in the expression logic. Expression logic here. Yeah, in your expression logic, but in this case, you can, yeah, you can also do it this way. Yeah, I just explained you, so you can use it in case you have some complicated statements. You can maybe sometimes write them in more easy way using De Morgan's law. Like maybe sometimes it's so if you have this expression like not a and, yeah, you can consider this this symbol as and. So if you, yeah, maybe I'll not okay, this is the mathematical expressions. If you are familiar with them, this means or, no, this means and, this means or, this means not, this means equivalence. Like we have one expression, then this means equivalent, and this means equivalent to this expression. So we have expression in the set P, then we have expression set Q. So we have not P or Q. It's the same that not P and not Q. Yeah. So, and why it's very nice to use them, because sometimes again in programming it's easy to use the same. It's easier and it's more convenient to use the same equivalent statement, not the statement. Like for example, sometimes it's, if you have this one, you can reconstruct it to this one, and that would look more easily. Or for example, if you just don't want to use these huge brackets, like imagine if you have multiple, sometimes you just use these brackets, then you write A or B or C. So in theory, so it means that that's the same as A or B. Yeah, you can use the brackets here, or B or C, which means using De Morgan's law you can write it this way: not A and not B or C, which means not A and not B and not C. Yeah, so in some cases, if you don't want to use too much brackets or a huge statement in brackets, you can easily split it in several different statements, and it may be easier for to understand it in your program. Okay, what else do we have? Okay, maybe that's the last one. Let's maybe finish with this and then we'll have the break. Just yeah, there's so-called defensive programming. That's about the assertions. So yeah, you use runtime assertions before code execution to check for correct preconditions. Yeah, that's also the way how you can use assertion. Like if you have the program and before you run the program, like you have some parameters, um, and yeah, using assertion, you can check if these parameters are passed correctly or not. And then after code execution, you can check if there are no problems. Yeah. Then it allows to handle incorrect inputs and passed parameters. That's what I said. And it doesn't make code much more complicated. That is what I said about the exceptions. Like you can in theory use the exceptions, but so since the assertions are used, as I said, only for checking purpose, not for the not to construct the actual program flow. So you use the assertions, and in this case you have just one assert statement without any this throws next to the method declaration, then try catch, and so on and so on. You just simply have assert and you get all the necessary information from the error, which, and as the result, it doesn't make code much more complicated. And if it is used correctly, then it doesn't affect system's performance too much and can be left in production. Yeah, you can leave. That's what I said. You can leave all the uh, all the asserts you have in your program, even in production system, but you can turn off the assertion handling, not handling, but assertion triggering. So in case you turn it off, you don't use this EA parameter in virtual machine. You just simply have these assert statements which will not be executed. They will just be skipped. And yeah, that's practically it about the exceptions. Yeah, let's have the break, and after the break we'll start. I will just maybe let's just have the break. After the break, I'll tell what will go next. What we'll do next. Okay, we can continue and let's yeah, maybe let's check what's on the home task for exception class. So yeah, just please note that we'll skip activity 07 because we will not talk about the UML diagrams. So we go forward to activity 0 08, yeah. So let's take a look on the requirements. So you will need to create the simple calculation exception class as a subclass of exception class. So as usually, yeah, for all the exception classes, and there you will need to implement two types of constructors. I mean, two types of constructor. Yeah, a simple constructor for the string, then another constructor for throwable class. Let's see, there's the question. Yeah, we can. Yeah, of course. I'm just explaining. So yeah, but activity 06 and extra 06 are till the end of this week. This one will be for next week. Yeah. So I'm just preparing. So you so you will be able to start it next week. Yeah. Just yeah, and so you have to create two constructors. Then in a simple calculation class, you need to have to implement mathematical operations uh, with integer numbers in range of -10, 10. So we need to validate the input using input range. You need to validate the input range using assertions. If they are disabled, then inputs can be any integer, and yeah, outputs are always checked and exception is thrown if it's outside the valid range. Yeah. So okay, I see there are the questions. Exception folder. Yeah, I will push. I'll push the code examples, and okay, maybe I can push them now. So or yeah, maybe I can push them now to not forget to do it after that. So the presentation. So I don't really remember. Okay, no, maybe let's just. So okay, here's the presentation, and so let me push the changes as well. So I think okay, it's not available in the console. And oh no, I actually do have Git staging here. Okay, and let me comment. Okay, so the changes are pushed. Okay, regarding activity 08. Regarding activity 08. So, yeah, here you need to implement some simple operations. Yeah, and throw the exceptions if the input is incorrect. Yeah. So yeah, I think that's pretty straightforward here. In case you have any questions about this, we'll discuss them next week. And regarding extra 07, extra 08. So what do we have here? Um, Let me check. What about the input stream? Okay. No, there is no input stream. It will be just tested by unit test. Yeah. Of course, you can. So just to check it by yourself. You can, as usual, you can create the main method. Oh, sorry. You can create main method and test everything you want from here. Yeah. But the input stream is not needed here because the parameters will be passed by unit tests. Yeah. Okay. So if we go to activity, not to activity, to extra 08 exercise. So okay, what do you need to do here? So yeah, there are three classes: invoice manager. So here you need to yeah, we can use annotations. So okay, maybe I will explain about annotations a little bit next week on Monday. So maybe I will note it for myself. Okay, yeah, I will note it for myself just to remember to explain you a little bit about the annotations. Yeah. Just one moment. Let me note it for myself to do a little explanation about the annotations. Yes, so here you need to annotate the stuff here. Yeah, basically this is, so almost everything here is related to annotations. Yeah, here, and here as well. So here is the initialization set of items. That's a bit interesting because we'll talk about the collections a little bit later. So yeah, I think that you can go with activity 08 until the until the until the end of next week. So I think we'll have the whole week for the discussion. Yeah, until 27. Okay, let me just show you what I'm writing here. 27th, yeah. And the active, and about X208 I will inform you a little bit later once we finish the topic about the collections, because you can see here there are the sets used, which but this is the part of the collection, so we will we'll discuss it a little bit later once we finish the topic of 4 collections. Yeah. Okay, what else do we have here? Just a simple setup. Yeah, annotations as well. Yeah, maybe I'll need to explain you next week. Then there are the sets. Yeah, I'll explain this next week. Yeah, it would be. Okay, maybe let me. Okay, let's just quickly go through, check if. Yeah, there's about database. I think that's X208. I think we'll need more topics to cover before X208 is before doing X208. But if you want to explore a little bit more, you can start doing X208. Just maybe we'll come to it a little bit later. Okay, so that's pretty it about the exceptions, and we can start with interesting topic about collections. So what are the collections in programming? And not only in Java, but we can apply it to almost all the programming languages. So basically, we have the items, like it can be whatever you want. Yeah, basically, in theory, that can be the list of items, the table of items, just whatever you can imagine. And the idea is that, like, we have this list, this table. Yeah, it can be like in real life, it can be like the box, for example, and you have some items inside this box. And yeah, in programming, the collection, that's basically the place where the items are stored. And imagine that you need to transport these items. You need to access the what you need to do with these items. You need to access them. You need to transport them. You need to, like, for example, if these are kind of numeric or text variables, you can sort them. Then sort them by name, For example, you can insert something new inside these collections. You need to fetch something based on some criteria. Then you may need to delete something, remove something from the collection, um, check something, and so on and so on. Just you can imagine comparing with. You can compare it with every list of items in real life. Yeah. What else do we need to think about before we start talking about the collections? Just let's maybe. Oops. Sorry. So imagine you have them. Yeah, and before we start talking about most usual cases, the list should be the list of the items with the same type. Have one item, two, three, and so on and so on. Have like n items. So the number of items must be finite, yeah. And again, as I said, so this is the collection. This is the list. Basically, yeah, the collection and the list quite the same thing. Like maybe with some specifications, but yeah, collection is more general. Think in Java there are the lists and there are the so-called map classes. As it states, okay, I think my presentation is closed for some way. Let me open it again. Moment. So there are in Java there are the lists, there are sets, queues, and maps, and more general, all these are the collections with some items. Right? What are the potential problems and the things we need to think about when we are working with these collections? The first one is, of course, memory. Like we need to think about the way the items are stored in a memory. Then we need to think about the way how the items are linked, because yeah, we can imagine that there exists kind of box or the place where these items are stored, but from program point of view there can be so many different ways how these items can be linked. So in theory you can link them like if they are set up in row. Like for example, you may have the reference, the pointer from this item, that the next item will be this one. The same is for this one. It points that the next item is this one, and so on and so on. So in theory, these items can be linked this way. It can also be done in opposite way or in both ways. So you point that the next item is this one, and from this item point of view, point that the previous item was this one. That's one way. Again, you can have the array. For example, in array you have also the elements which just go straight forward in memory from one to another, and so on and so on. So there can be, we'll talk about how the items can be linked with each other and how they can be stored as well. So yeah, what else do we need to think about? Like maybe let's not go deep. Imagine we have the table, yeah. So that's simple, like Excel table, whatever you want, yeah. So we have entries, one entry, first entry, second entry, and so on and so on. You have like again n entries, for example. What do we need to think about? We want to select the specific entry. Like for imagine in the first column we have the IDs, yeah. Imagine that's, for example, the name, yeah. You have one person with ID 1, second person with ID any specific ID, and so on and so on. And imagine we need to fetch the corresponding person from the table. Like we have the name and we want to find this person. What are the potential problems for this search from the programming perspective? We must think about how this search happens. Like, of course, what we want to achieve, what we always want to achieve, is to have the fastest possible algorithm to fetch the data. So we think about the memory, we think about the way how we can insert, because we can insert it, like in theory we can insert it at the beginning, we can insert the item at the end, at the middle. Basically there are so many different options. So again, memory, storage, how to read the data, how to insert the data, and like if you want to delete the data, that's also quite similar to if we read the data. But so yeah, if you want to delete, it's so first of all you need to read something. Actually, you need to read the corresponding entry you need to find the corresponding entry, and then you need to delete. And after the entry is deleted, like imagine you want to delete this entry, just random entry on position M, so you delete. So first of all you need to find this entry, that's the finding procedure. Then you need to delete this entry, that's the second procedure. And what happens after the entry is deleted? You have the collection with which is not the same, which is not actually the same as the same collection before the deletion. And we must think about what happens with the collection after the one entry is deleted. So does it need to be regrouped, or does the sequence needs to be changed based on the structure of this table? And yeah, these are the basic things what we must think about. And yeah, so the sequence, we also need to think about the sequence of the entries. Like if we insert, we can insert at the beginning, at the end, or somewhere else. And if we want to fetch, same way. Yeah, so the same things about if we want to fetch the entries. So the most popular, and yeah, there are some different popular structures of the tables. So the simple one is the standard one. Just if you have the table, you put something inside the table, then you read something from the table. You can have the keys of the table. That's also a very important thing. Like you have the entries, and you know that the ID is the key, so it should be unique. Yeah, the keys of the table must be unique entries. Like imagine you have the ID of the person, a personal ID for each person. In theory, the names can be same for different person. Even the name and surname can be different for different persons, but the key, the ID, must be unique. This is what about the tables. And like if we want to read the person by name, in theory we can get multiple entries from the table. And by surname as well we can have some multiple entries. If we read it by ID, there should be only one result. What else? Regarding the keys, you can have the multiple fields as the key chain. So you have the field ID, then you have like the field ID 2, for example, somewhere here, ID 1 and ID 2. Like there are two IDs here for each person. and both of them are declared as the key, so it means that this is one key. The key contains ID 1 and ID 2, and if we use both of them, this combination should be unique. Like in theory, you can have ID 1 like 1, 2, 3, 4, 5. Then for ID 2, you can also have 1, 2, 3, 4, 5. And in theory, you can have some duplicates in ID 1. Yeah, like you can have two persons with ID 1, for example, or more. But if you go to ID 2, you must there must be two different IDs in ID 2. So yeah, the key, yeah, like in this case, that's the simple key. Key is ID 1 plus ID 2. Yeah, that's the simple way how the tables work. Yeah, so we have table with the keys, and there are three types. Yeah, maybe three most used types of the table. So there can be the simple table, like if you have the keys. That's also that's have the keys, and you just have the entries inside the table with no specific restrictions. Yeah, like you need to have the unique ID. That's fine, but yeah, there are no other restrictions. You can have the not random, but yeah, maybe let's call it random sequence of the entries, like with the IDs are not sorted. They are just placed in the table in random way. Then another type of table is sorted table. It means that it must be sorted, and most usual case table must be sorted by IDs. So we have the not IDs but the keys. Yeah, like you have the key, and that can be the numbers or the symbols. Then we just then the table needs to be sorted. And what happens in this case? In this case, it's yeah, you have the sorted table with sorted keys from the beginning till the end. And where are the complicities here? Like imagine if you want to insert a new entry in this table. What you need to do? First of all, you need to follow the sequence. Yeah, not first of all, but you need to follow the sequence. Follow the sequence of the entries in the table. If you enter something, you must enter it in the way that the table remains sorted. Otherwise, there can be different problems. Depends on the program you are working with or on. Yeah, program you are working on. And I think you can understand that if you want to insert something inside the sorted table, it takes in average more time than if you just simply add, like in a standard table you can just simply add it at the end of the table, or basically at any position you want without any, so it's just one step. Yeah, add something to last position. Yeah, for example, if you do the same for the sorted table, again you must think that you must enter this one in the right position so the table remains sorted. To do it, you must first of all you must find the place where to add this entry. Like it can be somewhere in the middle. Yeah, you have A, B, C, D. then you have the entry E, or not, yeah, like you have A, B, C, D, A, B, C, D, no, A, B, C, E, let it be, and you want to add the entry D, so, and yeah, here you have the indexes 1, 2, 3, 4, and you want to add D, and so it means that the D will come on the 4th index. That means that first of all you create a new entry on the table with the 5th index where you place the value of E, yeah, and then on the so then it goes here, and on the 4th place there comes D letter. So you basically have 2 operations here. No, you have 3 operations. First operation is you need to find the correct place where to add this this value, right? Then you need to move all the other values. Like in this case, that's only E, but if we have more, then the same operation needs to be done for all the values which are below this D, for this 4th index in this case, yeah. So I must consider that if you want to insert something into the sorted table, you in most cases you'll need, not most cases, in average case, you'll need to reallocate all the entries, not all the entries, but a lot of entries from this table to different places. And yeah, as you understand, it takes more time to be executed. Yeah, but so you may ask, what are the advantages of sorted table then, if you just need to like if you want to insert or delete. So yeah, for delete that would be easier, but for to insert something you need to do so much operations. Yeah, that's tricky one, and yeah, it takes more time. But imagine if you want to read something using the key from this table. Like if you have the simple table, you can apply some different algorithms to read the entries. So basically, in theory, you can just go through all the table and read the entries. And in worst case, if you start from the beginning, you have 1, 2, 3, 4, 5, and so on, you can have n steps to find the right entry. But imagine you have the sorted table, and you have the key, and you want to find the entry using the key. Yeah. What you can do in this way? In this way, you can what you can do? You can split this table in 2 parts. Like so, here will be n divided by 2, the half of n, and check. Like so, we have sorted table, and here we have the key. Like let be key k. Yeah. And here we are on the middle, and we check 2 entries above, 1 entry above and 1 entry below this middle point. So if k is not, maybe let's not overcomplicate. Like imagine we have the exact entry at the middle. Yeah, we have the entry at the middle, and we check if k is greater. If k is greater than the value of this and of the key of this entry. So we must note that all the values here will be will be less than k. So it means that the k the key the entry with this key should be somewhere in the below, because key is greater than the middle one. So it means that everything what is about the middle will be less than k, and we don't really need to check for them. Right, then we go to the middle, and here we can do the same operation. We can split this table in two parts and do the search in the same way. So we go here, so it will be n divided by 4, and here we check if this middle entry is less than k. Then we go down. If it's greater than k, then we go up. So in this case we just split, and at the end we'll have less entries to check. So this means that from reading point of view, so we can simply read. No. You most likely you need the key to get the whole entry of the table. So you have entry, there's key, and then there are some values: value 1, value 2, value 3, and so on. And based on the key, you need to find the right entry. And that's regarding the question from Marita. Yeah, that's why we need to use the key. Yeah. Also, you can like if you just want to check if the entry with the corresponding key is inside the table, so you can just use it also the same way. Find something, but don't return anything. Yeah, that's also the way. You can just search for the entry and then return like true or false if entry exists or not. Right, and that's what about the sorted tables. You don't need to check all the entries every time. Like in starter table, to get the corresponding entry, you need to check all the fields in the table. If you have sorted table, again we split table in two parts. Then we check if this entry in the middle is greater than k. If it's greater than k, then we go up. If it's less than k, we go down. So it means that k is greater than the middle, and d and k will not be here. I hope you understand this idea. Oh, this is called binary search. Yeah, when we do the split of the table. So I hope you understand the idea why this algorithm is faster if we want to read. Yeah, that's for the sorted table. And maybe the most complicated way of tables are so-called hashed tables. And yeah, that's maybe that will take time to explain it. But the idea is that there is the specific hash function. Like imagine like every function you have just function which returns you some value. And what does the hash function do? It based on the key, like you have the key, and you provide this key to the function, which returns you the index of the table, and the index where the place where this particular key, the entry with this particular key is stored. Like yeah, just like imagine you create the table, then for each then no, not for each, but there is a hash function used for this table, and you just simply want to get the entry from this table. So you know the key, you provide the key, and you get the index where this entry is stored. And maybe as you can assume that from this case you have the constant time, right? So every time what happens, you just say I want to get the entry with ID X, for example. Let's not do it here. I think I don't have the place. To write here. So just maybe let's imagine we have the table here, just a simple table with the entries, blah blah blah, and with the key. So you have the hash function. Let's imagine that's the function which returns the index of the place where this particular entry is stored. So what happens? You ask like I want to get the entry with this where's this key. So we ask the function to get this entry, and this will return us the index from the table. So I want to, and for example, this will be index X, for example. Yeah, index X. Yeah, this one. So using the function, we can find the corresponding entry from the table. And why do we need this? Because the idea is that here we have the constant time. Of course, this it is based on the hash function and how is it implemented. But yeah, in general way, we have the constant time. What are the disadvantages for the hashed tables and hashed functions? You have the constant time, yeah, that's true, but if we have small tables, then in most cases, like small tables with not so much entries, again, it depends on what are the hardware you're working with. But imagine just for you have an average hardware, then if you have the table with just a few entries inside, and for this purpose the hash way of table will work much more slower than the average or even the worst case of reading for a standard basic table without not sorted, not hashed. Yeah. But what are the advantages? So yeah, this is disadvantage because you need to do the hash calculation using hash function. That will take a little bit time before where this function calculates the corresponding value and returns it to you. Also, there are some hash administration code used in hashed function. There's hash values which are also stored in the table. It takes more memory as well, and yeah, more time comparing to small tables. But what is the advantage? Advantage is the constant time, as I said. And if you have the table with a huge amount of entries, very huge amount of entries, like millions of entries, and you want to read read the corresponding entry from this table. In this case, imagine if you have just a simple standard table, that would be a suicide if you just simply check all the 1 million, all the million entries from this table to find one exact entry. Yeah, Marta, I'll answer you. Yeah, but if you have the hash function, you have the constant time for reading. So that time will be, so you just need to calculate the index using the hash function, which will return you the place in the table where your entry is stored. So in this case, that would take much less time than the same read using the simple standard table or even sorted table, because again the binary search will also can take a little bit time comparing to hash table, which just returns you the place in constant time. And yeah, there's the question from Marita, what does constant time means? It means that there's the fixed time, or almost fixed, yeah, because hash because the execution of hash function can also be a little bit different for different amount of entries, but in general we consider that this time is fixed. I mean the time when where you pass the key, then the function calculates you the index in the index the row, yeah, maybe that would be easier for you, the row where the entry is stored, so the number of row, the place, yeah, the index of row where the entry with this key is stored, and it will return you the entry. So this is the constant, the fixed time for all the reads. Like if you have the simple table, you can have you have n entries and you want to read the entry with one specific key. So in the and the idea of your algorithm is basically then you just read you just go through all the entries and you check first entry if the ID equals to the key provided. If true, then you return this entry, otherwise go to the next entry and check it. And the same for all the entries. So in best case you match the right entry at the first position. In worst case you match it, you find it on the last position, or you don't find it at all. Yeah. In this case, so you can have so the time is, let's just call it from, so the time is basically the number of steps, number of search steps done. Yeah. So if you have one, so let's just simply think that the time let's just call that the time is 1, which is the best case. In the best case you have time 1. In the worst case you have n steps to be done. And in hash function, this is just a fixed time to read the entries with the exact key, the entry with the exact key in the table. Okay, I think that's pretty it about the introduction of the tables, and also for the collections. We'll continue this discussion on collections in Java on Monday, and now we can go to our question and answer session. So I see there are some questions already came. Maybe let's start from the first one. Sandra asked about the debugging without break. Okay, we can have the breaks for that one, yeah. Okay, yeah, as usual we can have the break. Sorry, I forgot. Let's meet at uh, 12:30. As usual, yeah. So thanks for reminding me. Let's have a break, and after the break we'll go to question and answer session. Okay, let's move on to the questions, and yeah, let's start with with the debugging question. So first of all, for unit test, as I said, by default there is the timeout, time setup. So it won't be easy to debug this the current way. What you can do, first of all, what's as I said, you can download new, not new software, so yeah, you can go to Eclipse Marketplace, and in the marketplace you can find such tool. You can find many tools here, but in the same time you can find such tool like decompiler, yeah. Decompilers, which basically means that you just decompile, you translate your bytecode into the, not your bytecode of the Java program to the text code. So I have already installed, you can install it yourself. Enhanced class compiler. So once it is installed, you can decompile the classes. And for the unit tests, maybe let's go on this amphibia test. So you have for all the unit test classes, you have the class. So yeah, you have the class which is extended by this particular unit test class. Like in this case, that's encapsulation test, and we can find the place where this class is located. Yeah, and yeah, by default you see that class not found, but you can excuse me, what you can do, you can open with kind of GD core, for example, and you will see the code what is inside. And yeah, the same with others, but basically this is not what you really are interested in. Just what we are interested in to be able to debug the code. We can also see that all the classes of the unit test classes in our package are extended from this class GTM test. And in your case, not in your case, by default, so this is the default class GTM test. So they compile it. You can see that there's the timeout set up, and we are not really allowed to to debug more than like 10 seconds. What we can do is to basically copy everything from this class and create our own class here. That's the simple project. Our project main, and we have GTM test suite, and here we can create this GTM class. Maybe I can even more. I can pass the logic to you if you want. So you create the class here, and here just for testing purpose you just skip these timeout setup. Yeah. After that you will easily be able to debug without the timeout. Even more, I think you don't really need to you don't really need to to decompile anything, just create the class GTM test here under the test suite, and after that you will be able to to debug your unit test without any impact, uh, yeah, without any timeouts and without any impact on the results. That's about the class. And yeah, once this is done, what you can do is you can debug code like for which classes you don't have. Basically, these are the classes from GR. Yeah, but as I just said, you don't really need them to be to be available here. What you just need to do is, I mean, here you can create the class GTM test. Yeah, this one is not really needed. I mean, in this package, I think you should have this package. Just paste the code, create the class GTM test that pastes the code. I just shared with you in Discord. Yeah. So once it is done, you should not have this timeout issue once you do the debugging. Yeah. Okay. That's for the timeout issue. If if you want to debug after that, you can put the breakpoint in your program at the actual place where something happens, and like for unit tests you can run it as debug as JUnit test. You press on debug and then you can move on with the debugging. Of course, if you want, you can go through all this unit test stuff, which is placed in unit test classes, but I'm not sure if it's really important for you. Like if you what I recommend to do, if you have some issues with the unit tests of your classes, like with Martian, I'm not sure if there are any issues here. Sorry, not here. Yeah. Like, if you are on JUnit test here, you can see that there is the error, and you can see that there's the error after vomiting. So we can, like as the example, we can go to class Martian. You can go to vomiting and just same way run as JUnit test, and here we go. Yeah, we check what happens here. Same, we can also put the breakpoint here. I'm not sure if we'll go here. Okay, anyway, yeah. And then you can also check the metadata, for example. Just follow all the steps in the debugger. Yeah, so I hope that it's pretty clear how to use the debugger for the unit tests. Yeah, Sandra, are there? Yeah, okay. It seems that it's clear for you, Sandra, here. Okay, let's let's move on with other questions. I see. Okay, Sandra. Mhm. Okay, from Zana. Oh no, from Zana that was fine from yesterday. Okay, from Helen, yeah. Okay, Helen is asking about the testing. How can she test the human class? You cannot separately, at least in this case, you cannot separately test the human class. You just only have the unit tests. So you run the unit test and you check for results here. If you want to test human class in particular, like any methods you want to test here, you put the breakpoint here, breakpoint basically the place where you think you may have any issues. Then you run your sorry, not run, but debug your debug the unit test, yeah. Debug the unit test, and here you can go through the logic and see, using the variables, you can see how the variables are changed during the execution of the program. And yeah, basically it means that this unit test is for all the classes here, yeah. That's for Helena. Yeah, regarding that class issue, Svetlana. So once we go through all the questions from regarding the home task, I think we can move on with your class path issue as well. Yeah. So from Ilza, activity 06. Yeah, if you have this Java language assertion error, it most likely means that you don't have all the methods implemented, I guess, or maybe something is wrong with them. As I remember, it should be there can be the issue that something is not implemented, and maybe you missed some methods. Just maybe. So what's the class? The class human, yeah. So maybe let me just let me just tell you which methods need to be here. So first of all, you need to have okay, about the global variables. That's on you. Then you need to have the constructor without the parameters. Then you need to have the constructor of human with weight parameter. Yeah. Then you need to have the method kill himself without any parameters and return string. Then you need to have the method vomit, which returns integer. Then you need to have the method eat, which returns nothing, which is just the void, with the parameter to import with type integer. Then you have the method is alive, which returns string. Then you you have the method get getter of weight, then string to string, then if you want to use it, yeah, you can have the method which retrieves you the content of the stomach, and then the method which sets the content of the stomach. So user, please check if you have all these methods. If you still have this issue, maybe please share the code with me so I can go through it. And so you have the question why input replace all from 0 to 9 does not work. One moment. Let me check. So we have replace all. Just one moment. Excuse me, one moment. I have. Excuse me. Some local problems here. Yeah, okay, let me check. So regarding user, yeah, user, you have the problem that, as I understand the input, that's the string. That's the string, but you want to replace all non not digits with 0. But I think in your case you need to replace them with just empty space. Not space, but just with empty character. Yeah, like in this case. Okay, I said it's really awesome. That's okay. And user, if you still, so yeah, I just after I set which methods need to be in this class, yeah, please recheck and share the code with me if you still have the same problem. Okay, question, yeah. Yeah, question from Christine. 206 holiday. Okay. So regarding Regarding holiday 06, let's check. Holiday. Um, yeah, how you can iterate through the list of holiday. You can use something like this. So this is the way you can iterate through the list of holidays. Yeah, that's also the way. And after that, in the variable age, you'll get the value for the holiday. Yeah, this is for cycle, but inside for cycle here, I think it's fine if you use if else. If you use if else, that's fine. Months. Yeah, that's fine if you use if else. In theory, you can also find some maybe date libraries. That's for holiday. And yeah, to go to next holiday, yeah, I think that's and yeah, but just basically to go next, it goes through all the holidays, yeah. So that's basically the way how you will get to the next one. Yeah, Christine, this approach using for, so you have for, then you have declare the variable and which goes through all the values from holiday. Get next, you just since this is the cycle, you can use continue statement, yeah, if you want to go to the next. So since this is just a simple cycle, you can use continue to go to the next iteration, yeah. Continue statement. So just maybe let me just explain what I'm talking about. Additional cycle, like if you have the string list array, yeah, equals new string, doesn't matter how much. Okay, if we have the method, just simply for, we have string s, and we have the array, then we'll have 12 iterations here, and if we want to go to the next one, so by default it will go through all the like maybe let's have kind of 4, just have a simple, just a simple, like A, B, C, D, so just the basic characters and just simple S, yeah. Here you can see that all the values are printed. If we just like if S equals B, we can skip, for example, if you want to skip the B, then press them when we can use continue after that. So we can use continue, which means that we just go to the next iteration and we skip B. Yeah, basically for cycles this is the same as get next, yeah. Can use continue. Okay, yeah, the question from Ilse. About regular expressions, yeah. Okay, let's check. Yeah, but Ilse, do you have the returning? So as you can see, okay, maybe let's just let's have a new one. So if we have a string text, and here we have like I think that be Kelly, for example, then let's print out yeah, if you okay, let me just copy what I've written here. Just be this way, some kind of this way, and okay, what was the class for? Oh, sorry. Yeah, that's fine. Okay, so we can see here that nothing changes because that it does not work as the reference. It creates a new string. So this is absolutely different variable which is returned. Yeah. So Ilse, I think that was the problem you have.
Okay, thank you.
Yeah. So because you didn't return, so you didn't assign a new value to your text. For yeah. Okay. The question from Lena. That LLF issue. Imagine someone else code and you said it's a simple thing to so you indicate just so yeah we has the problem to kill himself for I think that was for a Martian oh no for no that was for human okay you kill your maybe let me just do it this way so kill after human kills himself you should assign the value false to the variable is alive so you have the variable in the class is alive which is boolean. Then in kill himself you need to change this value to false I think Boolean that's the issue you most likely have here yeah okay. Okay, so more questions? Yeah, Jose, do you still have this issue with assertion error or not?
Why I can manage to fix everything so fast.
Okay, yeah, please recheck if you have all the methods. Okay, and then
But yeah, I was missing the constructor. Thank you.
yeah, okay. Okay, so I need 1 minute, 1 minute, 1 minute break for myself. Just one moment. Okay, let's move on. So are there more questions? Okay, so I think then I can try to help Svetlana with the class pass. Yeah. Okay, so maybe Svetlana, can you try to share your screen? Just so I can, if possible.
Oh, yes, I will try.
Okay, yeah.
So it's again black. How to change it? How
Uh,
can I share my entire screen?
can you press on present now and okay, at least
Present
what I
now?
do, I press on present now and I select your entire screen. Then I have two screens and yeah, use the one I use. Okay, I have black one.
But why?
I'm not sure. I think we can ask Google about it. And that's
And what about Discord? Maybe I can
yeah
share my
yeah okay.
screen.
It's also fine. You can use any option you want to share screen. Yeah.
In general, voice, how to organize it in voice channels in general.
Uh, I'm not sure. That's my first experience with Discord. To be honest, maybe other girls know it better. Maybe start video call or okay, you have a voice channel, but what about the video channel? Okay. Wait, not this one. Sorry.
Okay. Can you see?
Yes.
If I show my eclipse, can you see it?
Um, yes.
Yes, it's okay. Okay.
Saturn, you need to turn off the microphone in one of the sources. I mean, in Google or in Discord. Yeah.
Oh yes. Oh yes. Give me a second.
Yeah.
That's okay.
Yeah, it's better.
Well, my eclipse, and I should go to the properties. Yes.
Mm. Oh, I just see your Discord, not the
Oh, you see
eclipse.
my
Yeah,
Discord.
yeah, not the eclipse.
Mm-hmm. Okay. Once again,
Yeah, sure.
share my screen. General Discord. Yeah, and on the Discord again. Yeah.
Yeah, no
I
problem.
don't know. And you cannot see Eclipse.
No.
How to do it? Maybe someone has experience in this. Because I cannot. Change window. Entire screen. Entire screen I choose.
Okay.
And now you see black screen, yeah?
Yes.
And now again black screen.
Still, yeah.
Oh, I'm so sorry.
No
How to do
problem.
it?
No problem.
Mm, I don't understand.
Do you have Linux or
Yes,
okay?
I
Yeah,
have
maybe.
Linux.
Yeah, maybe that's why. That's why.
Yeah.
Okay, maybe let's then try to go with the screenshots.
Okay.
Please, yeah. Okay.
Okay, so I stop streaming, yeah.
Yeah. Okay. Okay. Yeah. Then please share the. So what are the? Yeah. I mean, Zana, if there are no more questions, everyone else can log off. Yeah. It's fine. Yeah. If you don't have the questions, you can you can finish the session yourself. You can log off. Yeah, okay, thank you to those who want to log off. Yeah, but if you still have the questions, you can stay and ask. Sorry. Okay, for cloning, that's fine. If you have the questions about the cloning, I can help. Okay. So for the cloning, yeah, that may be a bit complicated for cloning. Okay, maybe let's see. Marita will push the code, so we can go through the cloning there. Yeah. State, yeah, temporary objects most usually work are used on the SQL syntax. Yeah, it's just for your information. Temporary tables are used if you deal with SQL. Yeah, okay, thanks, Marita. And let's try to go through the cloning Marita have. So I think you don't mind if I share the code with everyone. So that's the way we can discuss it. Okay, Marita. Excuse me. Okay. Okay, one moment. Let me copy the code. Moment. No, I'm not sharing the screen, but yeah, that's a good idea. Maybe I can go back to the screen sharing. Okay. Yeah, currently I'm just copying the code from Art, yeah. Moment. Okay, never mind. Just moment. Okay, for the Martian class, let's and for the coming, yeah. Okay, let's check. Let's check. Okay, object form. One moment. Okay. So, okay, what to we have here? Okay. Yeah. So, Marita, is this the error you are getting here? Is this the same? Yeah. Okay. So what's the problem here? It means that no pointer exception. You try to access the variable which is null. Yeah. Okay. Okay. Let's check. So that's fine now. If you, but okay, okay, maybe that's also fine. If you have null here, you. Okay, if it's integer, then return integer. If that's human, you cast the current one to human. Cast current one to human. Then you go, yeah, type human. Then you create new human. Okay. Then you. Okay, but okay, yeah, yeah. This human. It can omit only. Yeah, that's fine. Here you have Martian. Then you can cast a Martian. Then you create new Martian. Then new Martian can eat temporary Martian. Okay. Okay, and okay, maybe let's debug then. Because at first sight I cannot really see what's the issue here, but maybe yeah, it's so here, go here, go here. Okay. What? I just had different error. Okay, yeah, that's now I have different error. But I didn't do any change here. Okay. Okay, then. So properties of internal stomach are not called properly. Okay. So, okay, maybe let me just explain the clone method, because I just have so much mixes of code here. I'm not sure which one belongs to whom. So, basically, if it's null, then you should return no, that's fine, that's correct. If it's integer, then you should return. You don't really need to cast it here, because you'll return it to integer anyways, yeah? So you don't really need the casting here, because just you'll return object anyway, yeah? And then what you have here for the human, you need to, yeah, okay, you can cast it to a new one. Okay, you can cast it to human. Then you can create a new human. Yeah, but yeah, Marito, what you missed here, you need to set the weight for human as well, yeah? You haven't set the weight for human. Here you can just, maybe that's not the good approach if you eat, if you clone it with eating, just, you don't need to eat it again, you need to clone it, because so that's a little bit different. Um, so you need to set up the weight for new human so using different method. Then you need to copy the stomach, yeah. And to copy the stomach, you just need to you need to get so yeah, since this is the human, you just need to get weight of the stomach, yeah. So you need to set up weight and yeah, set up weight and what's inside the stomach in different methods, and method 8 is not really proper way to do it here. And for Martian you need to, so yeah, that's fine. And here that's also fine if you create new. But yeah, again, please don't really use vomit. Use different, not vomit, eat method. I recommend to use different method which set up the content from the stomach. Yeah. And yeah, you also need to set up the weight using different methods. So here, skip eat and eat methods. Just use set up the weight and set up the content of the stomach to your new human and new Martian. That's about cloning. That's about cloning. And for Martian, you need to, and one more thing for Martian. So here first of all, don't use eat. Here just use set what's eaten, like in my case I use set eaten. Yeah, set eaten. Basically, set up, just copy the stomach. Yeah, like in simple explanation, copy stomach content. Since this is the human, that can only be integers, so it's easy. For Martian, you need to, and yeah, and also copy weight as well. Yeah. For the Martian, almost the same, but not copy. Yeah, but clone, because so here is the tricky point that you need to clone the content of Martian stomach, because Martian can have different object inside the stomach, and that's why you need to have a new object in your new you need to have new object in your new Martian inside the stomach of your new Martian. Yeah. That's why you need to clone the stomach content of the stomach for Martian as well. And that's practically it about the cloning. Yeah, I agree that maybe that's the most tricky, that is the trickiest part here. So just please follow all the steps you have here. So if you have the object, you need to clone it. If you have the integer, you just simply can pass the value from one integer to another. That's about cloning. Okay, any other questions? Okay, see monitor step. Oh, yeah, okay. Any other questions? Yes, what what about your screenshots? Can you share?
And what should I? What?
Basically, what's the issue? Maybe as much screenshots from your Eclipse as you can. So please just uh,
Yes. Okay.
so yeah. First of all, yeah, how your project looks like, then your build path. Uh, it's property source. What's the source? What are the libraries here? Do you have JRE library? Some for Ilse, yeah, but okay. So if you have this, yeah, Ilse has error. This method must return result of object type. So okay, what do you return in this method? I mean, it should return the object variable like string or any other object. You cannot return the number. Like if you have primitive, any primitive value, you need to. Okay, thanks, Svetlana. Okay, in libraries, but can you expand JR system library? Svetlana, please. Okay. Yes, Svetlana, can you expand system library? Okay, seems that the content is here. Okay, and what's inside your source library? I mean here.
Source library. Oh yes.
How does it look? Yeah.
Give me a second.
Okay.
Yeah,
Just one
this one,
moment.
yeah.
Yeah. Okay. One moment. That's what was asked by. Just a moment. See. Okay. Let me check. So that one, can you? I mean, can you share this? Okay. Oh, okay. Yeah, that's fine. Okay, that's fine. So. So that's fine. Okay, that's also fine. And I mean, what's inside this source library?
In
Under
package explorer.
yeah, no, yeah, in packaging. Okay. Seems that all the packages are in place, and can you show the error you have, the exception?
Yes. For
Okay.
example, in some homeworks,
Yeah.
yeah,
Um,
I will run an
oh,
array,
okay.
for
But
example,
okay.
and make a screenshot.
Yeah. Mm. Mm. Okay, but I think that okay, that's the array. Yeah.
Yeah, it's for example, yeah. In any classes, I have some.
Okay.
um,
That's really interesting.
yeah, really interesting. I cannot understand because it looks okay. All libraries are.
Mm,
Yeah.
okay, then maybe you can just use these codes as an example, and you can create your own project. I mean,
Yeah.
if you create a new
Yes.
file, new, because yeah, that's a bit tricky, and without touching by myself, it's a bit hard to. That would be a bit hard. So yeah, that's so for this. So for this, just create a new maybe a new project and use the code examples as them. Just copy paste them in your project, and I hope.
Yeah, just copy and paste.
Yeah,
Yeah,
yeah, yeah.
but in theory, we can uh, don't copy and paste from Bitbucket. Just update. Yeah, like we push
Mm.
without any copying and pasting. And the same way, take a code from Bitbucket.
Yes, you can use pull. Yeah,
Pull.
yeah,
Mm-hmm.
yeah. You can use pull, and after that you'll get the changes from Bitbucket, no, from your
Mm-hmm.
Git repository. Yeah.
Yeah. Okay, but not in my case. I really
Um.
try to use Maven, but for some reason it doesn't work for
Uh.
my.
Maybe.
Uh,
Okay. Yeah, but I think that in Linux you just need to type, I think, two commands, and that should work. I mean, in Linux that was just simple, yeah, command line. Just need to. Okay, maybe I'm not sure how did it work in your case, but
No, it usually work absolutely the same way.
okay,
Maven,
yeah,
Eclipse.
yeah, Eclipse, yeah,
Yeah,
and these two commands.
that case, no.
Okay, that's a bit interesting, but okay, so if you don't have issues with in general, I mean not in this
Yeah, in
particular case, yeah,
general,
okay,
with my home task, there is no any
yeah,
issues.
okay,
Okay.
that was good.
Yeah.
Okay, and okay,
Yeah.
let's see. There's the question from Ilse. Session has stuck overflow error. Okay, maybe let's check issue from Ilse. Okay. 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 Moment. Yeah, because I have different structure. Set. Oh yeah, you need to human. Okay. Hmm. Oh. Okay. Yeah. Yeah. For use you have the problem here. Mm. So you don't need to. So basically, what was the idea for Martian? In Martian, there is the idea that you need to that you have sorry you have the Martian, then Martian has stomach. Yeah, maybe that's just so we have one Martian. It has the stomach. Yeah, and in one stomach we can have integer. We can have another Martian integer human, and we can have integer or human or Martian. In this case, human and Martians are objects, and we need to clone them as well. That's why we clone them the same way we clone this one, so the general Martian, and we clone them recursively. What's in your but for human, we don't need to clone human this way, because human does not have any specific items except the integer inside the stomach. So for human, you just need to create a new human, and at the end you can see if you ask con, you must consider that at the end you must finish this recursion in some way. But here I don't see that you create a new object. So at the end you must create a new human at least. And yeah, you cannot clone. If you use recursion, you should understand how the recursion will it will be finished. So in this case, for human, you don't need to apply the recursion. For human, you need to just simply create a new human here, new human, and set up all the stuff for this guy. Yeah. Okay. So any more questions? Okay, if there are no questions now, then I think we can close this session. In case you have the questions, I will try to answer to them today and tomorrow. And yeah, but I hope that I managed to explain almost everything about activity 06 and yeah, extra 06 as well. So I hope that you now have all the knowledge to complete this exercise until the end of tomorrow. Okay, then have a nice weekend and see you on Monday, everyone. Bye.
Thank you. Bye.
Thank you. Bye.